Hey everyone, Mr. Fugay here. And in this video, we're going to talk about how to identify, draw, and find vertical angles and linear pair. So if you have a note sheet to follow along here, we will have definitions already written out here, and we're going to just work through a few problems. So there's three vocabulary terms we're going to start with. The first one we've already spoken about in the course, and that is adjacent angles. Angles that share a common side and a common vertex, but do not overlap. So just to reconfirm that definition with us, I have this drawing here for us where angle A here is labeled in blue, angle B labeled in red, and then angle C, which is the combination of those two, A and B, is here in purple. So just to confirm, A and B share a common side. Angle A and angle B share this common side right here, so check. They also share a common vertex. The vertex is down here. So this ray right here is the dividing line between A and B. But additionally, they do not overlap each other. So A is to the left side here and B is off to the right side here. So this is the reason why A and B would be considered an example of adjacent angles. Now, let's flip the script and let's talk about angle C and angle B. If we look at this here, angle C and B do actually share a side. They share this side right here that I'm writing in red. They also share a common vertex down here at the bottom. So while they both share both of these things, what they do not have is, well, let's rephrase it this way. They overlap, which is a problem. And so because of that, as you can see, angle B is here. Angle C is encompassing part of B. So angle B is inside of angle C. This would be an example of two that are non-adjacent to one another. Okay. So once we have that under our belt, let's go ahead and talk about the first two angle pairs that we're going to discuss in this course. And the first is a linear pair. Two adjacent angles that form a straight line. Their measures add up to 180. So one shorthand way to talk about this is that these two angles are going to both be adjacent and supplementary, which means they add to 180. So if we look at it from that perspective, let's take a look at this drawing over here. So we have angle 1, which is right here, and then we have angle 2 off here to the right. You can see that they're adjacent because they share that side in the middle and a vertex, and they don't overlap. And notice that the two angles, when I form it together, the blue and the green, form this nice straight line. That straight line measures 180 degrees. And so the conclusion that we can make by looking at this and the fact that angle 1 and angle 2, when I draw their little arcs, essentially create this semicircle. And that semicircle measures 180 degrees. So a conclusion we can make is that the measure of angle 1 plus the measure of angle 2 will always equal 180 when working with a linear pair. The last definition we're going to look at is vertical angles. And what makes this one different is that these are two non-adjacent angles. And as we'll see in a minute, you don't have to be overlapping to be non-adjacent. So we'll see that in a minute. They're always formed at an intersection of two lines specifically. So if we have more than two lines, yes, there are still some vertical angles, but we can only isolate to two lines. And we'll see that in future examples. The last detail I want to take away from this is that their measures will be equal. So once we identify a pair of vertical angles, we know the conclusion is that they're going to be equal. And let me explain why. So here we have two intersecting lines. So we have our red intersecting line, and then we have our green intersecting line. And what we're going to see here is, and I'll label this in black, angle 4 is adjacent to both angle 1 and adjacent to angle 3. But what it's not adjacent to is angle 2. So do you see how they're kind of across from each other? They're not adjacent because they do not share any common sides. 4 shares these two sides, 2 shares these two sides. So angle 2, the measure of angle 2, is going to equal the measure of angle 4 based on our definition of what a vertical angle is. But let's talk about why. Let me give you a for instance, all right? And this is just a sample of why this works. Let's say that angle 4 measures 60 degrees. Based on what we just talked about in the previous example, look at angle 4 and angle 1. They look very similar to what I have here because they are adjacent and then their non-common sides form that green line. So angle 4 and angle 1 are a linear pair, and we know linear pairs add up to 180. Angle 1 is going to have to measure 120 degrees. And now let's focus on angles 1 and 2. Angles 1 and 2 here are also going to be a linear pair because, once again, they are adjacent to one another and they form a straight line from their two angle measures, which forces angle 2 to be 60 degrees. So this is the reason why vertical angles are equal. It's essentially taking two linear pairs and matching them up with each other, and that forces them to be equal. So by default, in this example that I have here, angle 3 then would measure 120 degrees as well. So another conclusion we can make here is that the measure of angle 1 is equal to the measure of angle 3. So those are our definitions for this video. In the rest of the video, we're just going to look at some sample diagrams and figures and try to work through these. But linear pair, adjacent, supplementary, vertical angles are non-adjacent angles at an intersection, and those measures will be equal. So here's your first chance to take a look. All right, in the diagram below, I would like you to outline in green a linear pair. So take two angles that make a linear pair and highlight them in green. And then I want you to take a pair of vertical angles and highlight them in blue. Pause this video, try that out, and then press play when you are ready. So there's a variety of answers for this. So I'm going to use a green highlighter to highlight this. So for example, angles 1 and angle 2 are a linear pair. Angle 6 and angle 8 are a linear pair. Angle 5 and angle 7 are a linear pair. We can't compare 3 to 5, for example. Those are in different intersections. Will take us to other types of relationships we'll talk about later. And angles 3 and 4 are linear pairs. But these aren't the only possibilities. In fact, we could go with others. We could say 1 and 3, 2 and 4. We could say 5 and 6. We could say 7 and 8. So there's a lot of combinations here. Essentially, they need to be next to each other, and they need to form a straight line. That's ultimately what we need to look at. Now, if we talk about vertical angles, which we'll use a blue highlighter to denote that, that's going to be across from each other at the same intersection. So angle 3 and angle 2. That's an example of a pair of vertical angles. Another pair would be 5 and 8. But we have more that we can pick from this. All right. We also can choose 1 and 4, and we can also choose 6 and 7. So ultimately, there's a lot of combinations here when we create these intersections. So angles next to each other would be linear pairs at an intersection, and angles across from each other are considered vertical angles. And that's ultimately what we need to take away from this video. Looking at the next set of problems here, it says find the missing angle using either one of the properties of vertical angles of linear pairs. So go ahead and pause again, and then we'll go through both of these. So 51 degrees is formed by this red arc that I have drawn here. Angle X is formed by this green arc that I'm drawing here. And what you should hopefully see here, and I'll bring my highlighter in to emphasize this, is that those two angles form a straight line. So those two angles together form a straight line, a straight angle, which tells me it has to add to 180. These are an example of linear pairs. And in order to figure out their measures, we're going to subtract 51 from 180, since the total is 180. And that's going to give us a total here of 129. So X in this first example is equal to 129 degrees. However, in the second example, we're going to see that these are not adjacent. But as we can see, they are across from each other. So because they're across from each other at the same intersection, we are going to call them vertical angles. Vertical angles. Very common misspelling is to switch the A and the L. Vertical angles, and remember we said vertical angles are equal, so X is going to equal 112 degrees. Let's take a look at some of our final examples in this video, which will continue to confirm what linear pairs and vertical angles can use for us in problems. For these two, we're going to create an equation to solve for these. So again, go ahead and press pause right now. See if you can set these problems up, and then we'll go through them together. So we have vertical angles here on the left, vertical angles here on the right. What we're going to do is we can now set these two equal to each other since they're across from each other. So 6x plus 7 will equal 8x minus 17. Now we just have to perform the algebraic operations to help us solve for this. So it's really important to remember that vertical angles, when you identify them, whether they're numeric or whether they're algebraic, all you have to know about them is that they're equal to each other. That's going to be the most important thing. This is going to be 24, I believe, which makes x equal to 12. The second example, they are adjacent angles next to each other, but in addition to being adjacent, they form that straight line when you draw their arcs. So this is an example of a linear pair. Linear pairs, we will always take the two angle measures, so in this case 11x minus 15. We're going to then add 5x minus 13 and set that entire equation equal to 180 degrees. We'll now do the algebraic work. So we're going to combine like terms. That's going to be 28, I believe. Add 28 to both sides. 16x equals, that I believe is going to be 208. And last but not least, we're going to take 208 divided by 16. So x in this example is going to be 13. All right, it's time for our final questions here for this, and that is going to be another set of solving for x. So for this one, go ahead, press pause. I'm going to have answers pop up on the screen in about 10 seconds. Here are our answers for these. So for the first one, we are looking at linear pairs. So I took the 4x plus 7, which I have marked up there in red, added it to the 2x plus 5, which I've marked in green, and set it equal to 180. Solve the equation, and I got x equals 28. Now the other direction here says we want to find the measures of all four angles in each diagram. So in addition to this, now I'm going to take that 28 and I'm going to plug it in for x. And I'm going to plug it in for x. And then we need to find the other two that are not marked as well. So for the red one, I'm going to take 28 times 4, which is 112, add 7 to it. It looks like this angle measures 119 degrees. The next one here, if I take the 28 times 2, that gets 56, and I add 5 to that, I get 61. Now, one thing that can help us check and confirm is that 119 and 61 does add up to 180, which confirms even more that we're correct here. Now, I can also use vertical angles to help me with this, because if I look across the way here to the non-adjacent angle to the red one, we know that that's a vertical angle which will be equal, so that's 119. And likewise for the green 61, I can look across to the non-adjacent angle here and say that's 61. For the final question, we decided these were going to be vertical angles because they are non-adjacent to each other and they are across from each other at an intersection. So I set them equal and solve to get 3 as my answer. By plugging these in, the green angle is going to end up being 31 degrees, and lo and behold, the red one also does become 31 degrees. To figure out the final two angles, we're going to need to use the idea of a linear pair. Since these two are adjacent to each other, they are also supplementary. We're going to take 180 minus 31 from it, and that's going to tell me that this angle is 149 degrees. And likewise, across the way here, the other vertical angle to that 149 will be equal as well. So in short, linear pairs are supplementary, vertical angles are equal. They occur at intersections of two lines. That's the summary of the video, and I hope you found the examples and the definitions here helpful. Now it's time for you to go out and practice and try your best to work through these problems. So I wish you the best of luck, and thank you for watching this video.